Hi Perimal, how are you? Hello, hello. Perimal, I am audible or not? Okay, he has just left the meeting. Okay, so this is a problem solving session for week number 6. Uh, so we'll start the session shortly. We'll wait for a few minutes so that as many participants can join the session. Then we will start. Hey Ravina, am I audible? Am I audible? Ravina, Deepika. Yeah, Ravina, please unmute yourself. You have raised your hand, so unmute yourself and then speak into the mic. Does your raised hand mean that I'm audible? She just left the meeting. Okay, let's just wait for one more minute, then we'll start. Yeah. Can someone just confirm that I'm audible? Deepika, Perumal, Ravina, I'm audible or not? Kind of respond, otherwise I will not know that whether I'm audible or not to you guys. Gyana,
Sir?
I am audible, right?
Yes, sir.
Okay. Okay, so let's just start today's session. So this is the this this is the problem solving session week number 6. So this was supposed to happen yesterday, but there was PMRF symposium, so I had to attend there. I've just come back today noon. So the next classes will be on the usual time on Monday. So let's start today's session. Okay, so this is the problem solving session for thermal physics course, as all of you know. Okay, so the first problem that says due to uh, due to the van der Waals correction, the pressure exerted by a gas compared to an ideal gas will increase, decrease, remains same, or will be negligible. So unmute yourself and then tell me. So van der Waals gas or van der Waals equation of gas, that is quite different from ideal gas, right? There, for ideal gas equations, those assumptions were there the volume of the gas molecules were not considered, right? That was negligible, and there was no interaction between the gas molecules also. So what van der Waals did in his model is actually included those two things, and so extended the you know the made it more natural occurring. So I have given you these informations that volume of gas molecules are being considered here, and also the gas molecules are having some interaction, some sort of interactions in van der Waals model. So then tell me, or all of you know probably the van der Waals equations from plus 2 level. So this is quite simple, right? If you know the van der Waals equations, like if you have seen just probably just once, you could answer it. Jagajevan.
Yes, sir.
So what do you think? What will be the answer?
I think option D, sir.
So you are saying that the pressure exerted by a gas compared to an ideal gas will be negligible. So
Yes.
so you can neglect the pressure in van der Waals correction. There will be no pressure term. Okay, let's see. So let's see. So the difference is from ideal gas that van der Waals, I will write it as VDW van der Waals model considered first gas molecules will have some finite value for ideal gas. It was neglected, right? And second thing, there will be some sort of interactions between the gas molecules. Now, what is the ideal gas equation? What is the ideal gas equation? Jagajivan?
PV equal to nRT.
Yes, absolutely correct. PV is equal to nRT. So there is pressure is there, right? So external pressure, which is in the form of atmospheric pressure or the pressure outside the system we are considering, that will be always there, be it in ideal gas system or ideal gas model, or be it in van der Waals system. So your answer, where you have just said that pressure for van der Waals equations will be very much negligible compared to ideal gas, does it make sense any? So it doesn't make sense, right? So there will be the same amount of external pressure for ideal gas or also van der Waals gas. Now, if you remember the ideal gas equations, which is just Jagajivan pointed out correctly, this is PV is equal to nRT. But van der Waals gas equation is something like this, right? PV n square A V square V minus NB is equal to nRT. So this term, now please tell me Jagajivan, whether the pressure increase decrease remains same. I have written the equation, right? Now tell me. Renuka?
Uh, Sir, this is, I think, Van der Waals equation. Now only I'm entered, sir. I have not
Yeah. So
can see.
okay,
What about you tell?
okay. Yeah, so I will just reiterate once more. So the question is, in the van der Waals, due to the van der Waals correction, the pressure exerted by a gas compared to the ideal gas will increase or decrease or will remain same. And one of our friends Jagajivan commented that that will be negligible, but we have just seen that the external pressure for both the cases will be same. So the uh, the case of being negligible is not valid, or is wrong. So actually, it is quite inconclusive to say it will increase or decrease, because that does depend on the sign of A, right? So from the equation you can tell that if the sign of A, or the A's value, if it is negative, then it will be lesser, right? It will decrease. But if A is positive, then the pressure due to the van der Waals corrections will increase. So generally speaking, in most of the cases, the value of A is positive. That's why we can say that pressure will increase. But it is inconclusive. We are not doing. We are not going to. We are going to learn. We are not going to just answer it or to choose one option. So let me write. It depends on the sign of A. If A is negative, pressure decreases. So then pressure decreases, right? Because then this term, this effective term, let me write in terms of this P bar, or P, let me write it P hat, P tilde. This will be less than P, right? But if A is positive, then pressure increases. So depending on the sign of A, right, or value of A. So let me add one comment here, that most of the cases for gases, A is positive, then we can say it increases. But this also can happen. Okay. So is it understood? Any question? Jagajivan, is it clear now?
Yes, sir.
Good. But I like that you have attempted, at least.
Thank you, sir.
Yeah. Okay. So if not any questions or any doubt over this question, then let me proceed to the next problem. So the next problem says, calculate the van der Waals constant A and B for 1 mole of a gas having Tc, which is called the critical temperature, 65 Kelvin, and Pc, which is critical pressure, which is 7.6 times 10 to the power 5 Pascal, and the universal gas constant value is given. Now I hope that you guys are going through all the lectures of Professor Banerjee. Then it will be pretty much simpler for you guys, right? Otherwise, in this class, this is a problem solving session or doubt clearing session. if you guys are not following the lectures, then you will not able to you will not be able to solve the problems. So that's the thing. But I will help you guys by giving the formula. Then I will wait and I will get back to you guys. So first of all, one comment, so that you guys will get some idea about the critical points. So critical points are something where actually, you know, a critical point of a gas is defined like the point where if you actually draw the PT diagram, then this PT diagram, the PT phase diagram, at which this liquid and vapor phase, they actually terminates. So when the temperature is below that critical temperature, then there will be a phase in which the gas will be equilibrium, that gas state of that molecule will be in equilibrium with the liquid. So the gas has liquid state and the vapor state, which is like vapor means the gas in the form of we see in real life or in generally. So the gas will be there in equilibrium with the both the states, liquid and vapor. Let's say carbon dioxide. So when if temperature will be less than the critical temperature for carbon dioxide gas, then at that temperature, which is lesser than the critical temperature, liquid and vapor phases of carbon dioxide will be in equilibrium. Okay, so this is the from in a concept perspective. But to solve this thing, you just need to know the this formula. So this this is 27 r square tc squared divided by 64 pc, and b is rtc divided by, someone wants to join, let me allow him. So this is rtc by 8 pc. So tc is given 65 kelvin and pc is 7.6 times 10 to the power 5 Pascal. So please solve it and then tell me the answer. Which option is correct? Let me do it side by side. This is 27 times 8.31 square times 65 square divided by 64 times 7.6 times 10 to the power 5. And if you do it, and let me write for it. I want the answer. I want that you are guys doing the calculations. Anyone got any answer? This is simple. I have written all the formulas, and I have just also placed the values also. So this is just algebra. Okay, so looks like I have to give the answer straight away. So the answer for my case is happening 0.161956. What will be the uh, what will be the dimension? So this is Kelvin minus 2, and this is Kelvin square. That will cancels out. This is Pascal. Pascal means Newton per meter square, and this is Joule per mole Kelvin. You can also say that there is P plus n square A by V square. So P has the same dimension as n square A by V square. So A will be dimension of P V square divided by n square, right? So that actually comes to be a Newton meter to the power 4 mole minus 2. And for this one, it's coming out to be, for my case, let me calculate once more. 8.31 times 65 divided by 8 times 7.6 times 10 to the power 5. So that is coming 8.884 times 10 to the power minus 5, and this is meter cube by mole. So option B is correct one, right? So option B is correct. Okay, any question? Any question from this problem?
No, sir.
Okay. Did you get this answer, Renuka?
Yes, sir. Yes, sir. Some network issue, sir. That's only now delay, sir.
Okay. Let me proceed to the next problem. Okay, so the next problem says calculate the critical pressure of 1 mole of a helium gas using the van der Waals constants A, which the value is given, and B, that value is given 2, Then we have to calculate the critical pressure. So probably you guys don't remember the critical pressure formula for this one. Here the species is A by 27 B square. Okay, so then what will be the value or option, correct option? Tell me. That's fine. Which option is correct one?
Sir, option A.
Option A. Okay, okay. Let me see. Other I want more answers. But thank you for attending.
Thank you.
Yeah. Okay, so for my case, it is coming out to be 2.28926 10 to the power 5 Pascal. So probably you have done little mistake in the calculation. So
Yes, sir. Yes, sir.
this is the correct
Some
one.
mistakes, sir.
Yeah,
Sorry, sir.
yeah. No worries, no worries. So this is the correct uh, answer. So any problem or any queries for this question?
Sir, 1 second. Sir, PC value first of all calculate and then substitute the.
No,
Sir, 1 second you can tell me, sir.
yeah. Yes, Renuka. What is your question?
Tell me, sir. 1 second you can explain, sir.
Okay, so you
Not
want a
coming this answer.
okay. So this is there is so this critical pressure formula for this van der Waals equation, that is A by 27 B square. So A, B are the van der Waals constants, and those values are given in the question, right? Now I have just
Yes,
put,
sir.
so then I have just put those values. So after putting those values into the equation A by 27 B square, I have got this value. Have you put those value into the equation?
Okay, sir. I will check.
Okay, so what is your answer coming?
157, sir. What mistake? I don't know, sir. Once again, I will check after that, sir. You can carry on.
Okay. Probably you did it. Probably you just didn't didn't do the squared of this b square, b value. That could be the reason. Anyway, let me proceed to the next problem. So find out the Boyle's temperature using the critical constants given in the previous problem. So this is similar, like the values are the same. Do you know how to find the Boyle's temperature? What is Boyle's temperature first? Anyone?
TA equal to 2A by RP, sir.
No, that is the formula. I have asked what is Boyle's temperature. So we get the value 2a by rb from after doing some calculations, right? Or this is called Boyle's temperature for some reason, right? Okay, so these are the temperature which is called Boyle's temperature, at which, have you heard about the virial coefficients in the lecture? So what are the virial coefficients? So virial coefficients are some expansion, some terms when a gas deviates from its ideal nature, then we can write the gas equations in terms of some series. Okay, now in that series, the first term, second term, third term, there are infinite number of terms. A gas which is deviating from ideal gas, that will be perfect gas when all those virial coefficients will be zero at certain temperature. But it is practically it is impossible. So that's why, so physicists are very good at approximations. So that's why they say that when the first virial coefficient is zero, we can say that at that temperature it will behave like perfect gas. Okay, so let me just write what does it mean from equation perspective. So a compressibility factor Z is calculated when by taking PV by RT. By calculating this quantity PV by RT. Now this actually looks like 1 plus BT by V plus CT by V square, like this. Okay, so Boyle's temperature is that temperature. Boyle's temperature is when BT is 0. Okay, now what is the Van der Waals gas equations? This is N square A by V square times V minus NB nRT. You just divide it by N, it comes to be, so people write in terms of molar mass, molar volume. So this is molar volume. Okay, So we have just calculated in terms of this. Now, if is that the case, then so I have, so this is V like this, and if you just divide it by n both side, it comes out to be like this, right? So from, is it clear from this to this? How is it coming? Let me write V bar.
Yes, sir.
Okay, great. Now, if that is the case, then you can write in terms of P is equal to RT by V bar minus B minus A by V bar square. This is called molar volume. Now, let me get one V prime common from each side. So what that will be? So P will be, let's say, take RT by V prime. So first term will be V bar by V bar minus B, right? Second term will be A by RT V prime, right? Now take it this side, PV by RT will be, this is can be written in terms of a series, you can approximate it, right? V bar, take it common, 1 minus B by V bar plus minus A by RT by V prime. Someone want to join, just a minute. So is this point clear? So this is up until this point is clear, right? Now this can be written as 1 minus B by V prime minus 1 minus A by RT by V prime. So this is 1 plus B by V prime, okay, plus B by V prime squared minus dot 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 A by RT V prime. It's very challenging to to make someone enter into the class in the middle of doing something. Okay, so this will be 1 plus, so we will take the same term where the power of V are equal, means like the where we will bring those terms to get this kind of term, means we have to group the terms in terms of power of V prime, V bar. So this will be B, so let's say 1 by V prime, though this will be B minus A by RT, this is minus, right, plus no, no, no. So first virial coefficient is this one, right? Now if this is 0, let me add one, let me add one, let me add one. So to make Boyle's temperature means so this is the BT, this is the first virial coefficient. I have to make it 0, right? So if that is 0, if first virial coefficients is 0, then BT equals to 0, that is A minus, sorry, B minus A by RT, and that is Boyle temperature, right? This is TB, then equals to A by RB. So the value of the Boyle's temperature is A by RB. Okay, so Renuka, you are wrong. It's not 2A by RB, it's A by RB. So now we know the A from previous this thing, and you will use it. This is 3.59 10 to the power minus 3. So this is 3.59 10 to the power minus 3, and R value is 8.31, and B value is 2.41 times 10 to the power minus 5. Now tell me what is the temperature. Do the calculations and let me know.
Option B, sir.
Tell me the value.
17.88.
Okay. Anyone else? Jagajiban,
Yes, sir.
did you calculate?
Yes, sir. I will try.
You are trying right now.
Yes, sir. Yes, sir.
Yeah. Okay, looks like Renuka's answer closer. So for my calculation, it is coming to be, I don't know how Renuka got 17.88. For my calculation, it is coming out to be 7.92 Kelvin.
17.92.
Yes.
That's only nearly for B,
Okay.
B option.
Okay. That's why. That's why I have asked you the value. Anyway,
Okay.
you just got the correct answer. Thank you. So yeah. So 17.88 Kelvin, which is a closer value. So have you guys understood the derivation and why it is called Boyle's it's called temperature.
So 17.92
Yeah,
Is
yeah.
correct answer, sir?
Yes, yes.
Some technical problems, sir. Sorry.
Yeah, yeah.
I already said, sir.
Okay, okay. I didn't, I didn't hear it. So my mistake. Anyway,
Okay, sir. No
so
problem, sir.
yeah. So any question regarding this, or any doubt regarding the derivation, why it is called Boyle's temperature and all these things, this derivation? So this is called Boyle's temperature because it the way it goes is, since it is perfect gas, it will follow the Boyle's law. That's why it's called Boyle's temperature. And to follow that, we have to make the virial coefficients, all virial coefficients, 0, but which is impossible at certain temperature. That's why we have to make the dominant virial coefficient, which is the first virial coefficient, that to be 0. And we have calculated, we have did the thorough calculations, and we got to the point where, to get to be the first virial coefficient to be 0, the temperature has to be A by RB. Okay? Okay. The next problem. This is a problem from the +2 level. So you guys all did this kind of curve in your +2 level from in physics and also in chemistry also. The question says, what is the nature of isotherm? Isotherm means where temperature is constant. What is the nature of the isotherm in P versus PV plane for a gas obeying Boyle's law? So it obeys Boyle's law. So this is a perfect gas. PV varies as T. You know that PV is constant in that case. So if PV is constant for Boyle's law, then how the graph will look like?
Sir, I think horizontal straight line.
Great. Good. Anyone else? Why so? State your
Sir,
reason.
PV curve in the isotherm and adiabatic, isothermal expansion, adiabatic expansion, and then isothermal compression, adiabatic compression in the rectangular
No,
pattern.
wait. Why adiabatic and all these things coming here?
I am study about only PV curve. PV means that pattern, sir. That's only here isotherm word is there. That's only P
So
versus like that.
yeah,
I am telling.
I actually I understood. So whenever this isotherm, this curve first, we actually get to hear from in the Carnot engine, right? So there was like this isotherm curves and adiabatic curves, but here isotherm is a one definition, mere definition. Isotherm is where temperature is fixed, temperature is not changing. So here adiabatic is not needed. Adiabatic, the concept of adiabatic is also not introduced so far. So as you've just said, Renuka, that since it follows Boyle's law, PV will be constant because the temperature is not changing, right? So that's why it will be a horizontal straight line.
Okay, sir.
Yes, but your reasons are quite correct, but you are just you are
Yeah,
wondering
I might. Yes, sir.
different things. There is no need to mention adiabatic here, but anyway, thank you, you are doing quite good. So Boyle's law is PV is equal to constant when T is constant. So for isotherm, T does not change. So then the curve,
Sir, option C, sir.
why option C? Who is speaking? Jagajiban? Who is speaking?
Parabolic straight line is come, sir.
Why
I
parabolic?
think,
Why parabolic?
I think,
Yeah, tell me. No, you don't need to be hesitant. You don't need to be, you may be incorrect. You may be
sir,
wrong.
no, sir.
Yeah.
Renuka said horizontally straight lines, but I think parabolic straight line is comes.
Parabolic straight lines. Parabolic straight lines. Parabolic is parabolic. Straight line is straight line. Parabolic straight line. I'm not getting.
P versus PV plane for a gas or obeying Boyle's law, sir.
Huh.
That's, I think, parabolic straight line, sir.
I'm not still getting the point. Parabolic, parabolic, straight line, straight line. So what is parabolic straight line? I'm not getting that point. So here it follows Boyle's law, and that's why the curve of PV versus P will be horizontal straight line, because PV is constant, because T is also constant, because isotherm, the condition of thermalization or isotherm is given. So PV is constant, P is changing. Then how that would look like? P changes, PV is constant for every P value. For every P value, PV will be constant. So this will look like a straight line, right? Horizontal straight lines. So Renuka is right.
Sir, P is straight line or PV is straight line, sir?
No, this is the curve is PV versus P. So let's say there is one value of P, let's P1, and one value is P2. Now here it is
Okay, sir. I got it, sir. Got it.
okay. Probably you are not, you didn't, you missed the part of my question, first part of the question. That's why.
Yes, sir. Yes, sir. Yes, sir.
Anyway, so oh, okay. That's why you are telling P was. Now I'm getting the point. That's why we were getting that parabolic and straight line, because you are thinking like so P versus V, that will be parabolic, and P versus V, that will be constant, right? Am I correct?
Yes, sir. Yes, sir. Yes.
Yeah. Okay. Anyway, you guys are thinking, that's good. So probably I have to proceed to the next problem. So I will do this. Do you know how to? I will do the whole calculations, but I will get to know what will be the way to proceed. So here the question says, find the critical volume of a gas obeying the Dietrich's equations given by P is equal to this form, and from that you have to find the critical volume. Now, do you know how to find it? Anyone? Gyana Shekhar? Perumal, bike lover, and what the other? Let me find out the list. Deepika, help me to help me to think how we are going to get the critical volume, the way of doing the calculations. So what happens actually? What happens at critical point? So critical volume means the volume at critical point. Critical pressure means pressure at critical point. So in the beginning, I have stated that critical point is that point where the liquid phase and the vapor phase are in equilibrium. So if that is the equilibrium point, then if you get to that phase 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 transition will not be occurring. That will be a kind of a first derivative and second derivative both will be zero, right? At that temperature curve, that isotherm will be first derivative and second derivative both will be zero, right? Okay, so let me state it first. At critical point, dp t and del 2p t both are zero. From conceptually, you have to think like this. Isotherm will have no slope, means slope value is zero, and curvature zero. So P versus V in that region, it will be like straight line. So if that is the case, then we have to then solve it. P is given, then P is like this. Then it is straightforward calculations, right? This is straightforward calculation. What is the value coming out to be? Let me give you 2-3 minutes to solve it. Is it okay? So first you have to differentiate P with respect to V, keeping T fixed. Then again you have to differentiate once more, keeping T fixed. And there are two simultaneous equations, and you have to solve those two simultaneous equations to get the value of V. And that will be the Vc, the critical volume of that gas. So I'm giving you 2-3 minutes. Is it okay? Yes or no? Some answer I'm expecting.
Yes, sir. Yes, sir.
Okay. Okay, let me start, otherwise it will be late. So the trick is to, there is no trick involved here, because it is just simple differentiation. Okay, but if you do a certain way, the whole process will be easier and faster. Okay, so I will do that in that way. So first let me write here, I will write p dot, let me write p prime, because otherwise dot, this thing will come. Let me write dp by dv. Okay, so if that is the case, then if you take the log of this thing, log of p, I will keep all the constant, this term out of this, log of rt minus log of v minus b, and then minus of a by rtv. Now if you differentiate this equation number 1 with respect to v, first thing it will come is 1 by p times p prime, right? P prime is dp/dv. So first, this is simple differentiation. This is constant because t is constant, rt both are constant, so this is a constant value, so this will be 0. And for this thing again, minus 1 by v minus b, and for this thing plus a by rt v square. So in our case we have to, so this now in our language, in our symbol, it will be p prime t, p double prime t will be 0. So this is this thing. So we can write p prime as p divided by, sorry, times rt v square minus 1 minus v minus p. This is equation number 2. Now again we have to differentiate again. So if we differentiate again, then this becomes p double prime. First we differentiate this term, this will be p prime a by rt p square minus, this term will be as it is. Now again we will do this. This will be p, this will be a by, so this will be minus 2a by rt v cube minus, this will be 1 minus v minus b squared. Okay, this is equation number 3. Now our condition is given, p prime and p double prime both are 0. So from this equation we will get p prime equal to 0. So this equation will be 0. Let me write there. So from criticality, p prime equals to p double prime equals to 0. Then first equation, then from equation 2 it becomes p times a by rt v square minus 1 minus v minus b, that will be 0. Now we can write P cannot be 0, right? This is a finite pressure, finite temperature system. So since P is not equal to 0, then we will get A by RT V square is equal to 1 by V minus B. Let me write in terms of equation 4. Then from this equation, equation 3, we will put P double prime equal to 0, P prime equal to 0. So this term will vanish. Only this term will remain. So P times minus 2A divided by RT V cube plus 1 by V minus B whole square equals to 0. Now again we can say that P is equal to not 0. P doesn't need to be 0 because this is a finite system. So this will be 1 by V minus B whole square is equal to 2A divided by RT V cube. Now this from 4 and 5 we will what we will do, we will make it. So what will be the from equation 2? From equation 4 we'll get 1 by V minus B whole squared is A RT V square whole square. Now this also like this. Now let me name it equation number 6. Let's just make equation 5 divided by equation 6. So we'll do next operation will be equation 5 divided by equation 6, and that will give us, this will be 1, this term will be 1, so this will be 2A RT V square whole divided by, so V cube, sorry, RT V cube is A by RT V squared. This is 1. Now if this is 1, then after doing this thing, this will be R T V divided by 2 RTV divided by A equal to 1. So A will become 2 RTV. Okay. Now put this value into this one. Any equation 4, let's say. Okay. So if you put in equation 4, so this is equation number 7. So putting equation 7 into 4. So we will just substitute the value of A. So A value is 2 RTV. So 2 RTV divided by RTV square will be 1 by V minus B. That makes 2 by V is equal to V minus B. That makes V minus B is equal to V by T. That makes V by 2 is equal to B. So V equals to 2V. So what is it coming out to be? V is equal to 2V. So this is the correct answer. Okay. Any problem with this calculation? Isn't it simple? Yes, no, maybe. Any response? Any comments?
Yes, sir.
Okay. If not, I will just in the when we will in close the session, I will go through it once again. Okay. Okay. Now next problem. This problem I want all of you to do now. This problem says a platinum resistance thermometer reads 2.57 omega at 0 degree centigrade and 3.53 omega at 100 degree centigrade and 2.89 omega in a bath. Calculate the temperature of bath on platinum scale. So always remember, the 0 of centigrade scale is not absolute 0. At absolute 0, everything becomes 0. So one way to do this, there is some relation between the centigrade scale and the absolute scale, which is called Kelvin scale, which is the difference in centigrade scale are same as difference in absolute scale. Only the shift of origin is there in Kelvin scale. So we will first get, so let me write it here. So platinum scale and degree centigrade. So 2.57 when 0 degree centigrade, 3.53 when 100 degree centigrade. So what is the difference? Difference is 2.5 omega. So 0.96 omega, this difference indicates 100 degree centigrade difference. PT difference degree centigrade. Okay. Now what is the difference for this from this 2.37? So this will be 2.89 minus 2.57 ohm. This is not ohm, this is omega. So which is 0.32 omega. So if 0.96 omega is 100 degree centigrade, so then 0.32 difference, how much will be? It will be for 0.3 omega, this will be 100 by 3. That will be 33.3 degree centigrade difference, where this is 2.57. So 2.57 omega is at 0 degree centigrade. So the temperature will be T platinum is 33.3 degree centigrade plus for that is 0 degree centigrade. So 33.3 degree centigrade. Easy? Any questions? Any question?
No, sir.
Okay. Let me go to the next problem. Here the question says the length of the mercury column in a liquid thermometer is 0.06 meter when it is placed in water at temperature 0 degree centigrade. The same kind of thing. Calculate the length of the column in meter at the steam point. At the steam point. What is the steam point? So temperature at steam point is 100 degrees centigrade. Remember, mercury column will be 0 at 0 Kelvin. Then we have to transform it to Kelvin scale. People coming and going. Okay, so up to 0 point is 0. So 0.06 for 0 degree centigrade. For 0 degree centigrade is 273 Kelvin. So for 273 Kelvin, column height changes 0.06 meter. Then for 1 Kelvin, what will be that? That will be 0.06 divided by 2733. So at steam point, delta HS will be 0.06273 times 373. Let me calculate it. So this is coming out to, for my case, 0.0819 meter. So this is the closest option. Did you get the same answer? Did you get it?
0.0816, sir.
Okay. Okay, no problem. That is also the same thing, 0.082. Now, next problem. Next problem says, these are pretty simple problems. These are from school days. A constant volume hydrogen thermometer is used to measure the temperature of a furnace. It measures a pressure of 1 atm at 0 degree centigrade. So these are the same procedure of the previous one, right? So pressure will be 0. First assumption is pressure will be 0 at 0 Kelvin. So 0 degree centigrade means 273 Kelvin, and that temperature pressure is 1 atm. That means 101325. That is 101325 Pascal. So at for T is equal to T something, Tp pressure is 556781. So then T by 273 by Tp will be 101325 divided by 556781. So Tp will be 273 times 556781 divided by 101325. So 3 times 556781 divided by 101325. So for my case, it is coming out to be 1500.0 13 Kelvin. So this is the correct answer. Okay. Last problem today. I will cold call everyone for this problem. The question says a system A is neither in thermal equilibrium with B nor with C, then the system B and the system C, which of the options are correct or which of the option is correct? So let me just Gyanashekar. Hello, Gyanashekar, are you there? Gyanashekar, Perumal, Raghav, Raghav, Mani Rashi. This is simple, right? A system, there are three objects, let's say three objects, 1, 2 and 3, three objects. Now this is A, this is B and C. Question is, this one is not equilibrium with this, not equilibrium with this. Now what is the relation between these two? It can be in thermal equilibrium or cannot be, because we said that they are not thermal equilibrium with A. This is inconclusive information for to give one, to give one conclusive statement. What will be the relation?
Can be thermal equilibrium is correct, sir.
Cannot. What?
Can be.
But there is no option. Can be.
Cannot be thermal equilibrium, sir.
Cannot be. Okay. Cannot be.
What? Why cannot be in thermal equilibrium?
So that one will be give the option.
That one? What?
That will be the, giving the options. Yes, sir. But can be.
There is one options. Maybe in thermal equilibrium, right? It may be in thermal equilibrium also. It may be or may not be. Cannot be in thermal equilibrium is something you are just straight away refusing. It cannot be. But this is inconclusive. This is not conclusive. So cannot be in thermal equilibrium is not right option. So that is totally gone. Now maybe I'm just keeping aside. Maybe in thermal equilibrium it may be. So this statement is true. Maybe or may not be. Must be in thermal equilibrium, that is also incorrect. None of the above will not be correct, because there is one option, maybe in thermal equilibrium is there. So maybe in thermal equilibrium, that will be the correct option. Okay, because the relations between A and B will not. So the thing is, A not equal to B and A not equal to C. That doesn't mean that from here two possibility can happen. One is B equal to C or B not equal to C. Okay, so maybe or may not be.
Sir, you will be said can be or cannot be, so I will say can be.
Okay.
That
No,
thing,
that's
sir.
why I was saying that please look into the options.
Oh, okay, sir. Okay. I can't see the option, sir. Just
Why?
said you will. Sir, I just I will join now, sir. I will.
Okay. No problem. Okay. You are just listening then.
Yes, sir. Yes, sir.
Okay. So that's it. So that is the today's session. So I will just reiterate this long calculations because this is very much important. This kind of thing will be there in the exam for sure. So first thing first, to get the critical point, let me make it big. To get the critical point from any gas equation, you have to get the first derivative of p with respect to v at constant t, and the second derivative of p with respect to v at constant t. These two terms should be 0. If that is the case, here what I have done is, let me just switch to the pointer option. So I have just take the log of this, log of p, and this thing is constant. So if you just do the differentiation with respect to v of this equation, then first term will be 1 by p times p prime. P prime is dp dv. This term is constant, so this will be 0. For this thing, this will be 1 by v minus b, and there is 1 minus, and this thing will be a by rt v square. From here I can write p prime is equal to p times this term. Now from here we can just, to get the double derivative, we have to just differentiate this equation once more. So this will be p prime, p double prime is equal to the differentiation of both these two terms. So this will be, first is will be p prime a by rt v square minus 1 by v minus b, keeping this fixed, and this one will be p times, then for differentiation of this term, this is minus 2a by rt v cube plus 1 by v minus b square. And so for criticality, p prime and p double prime both should be 0. Then we will just first so first this so this is, it's not moving. So for this thing we will just put p prime and p double prime value equals to 0. So if we put p prime equals to 0, then we will keep, so this whole term will be 0, but p cannot be 0 because that is trivial. So this term will be 0. So I have written this term equal to 0. Then from this equation number 4, and from this thing, p prime is equal to 0, p double prime is equal to 0, and p prime is equal to 0. So this term blows up, this term goes out, this term goes out. So this term only remains. So from here p cannot also be 0. So this is, from this term will be there. Now I have squared this. I have taken the square of both these two terms. So from here 1 minus b whole square is equal to a by rt v square whole square, and then I have just I have just divided equation 5 with respect to equation 6. This will this, and from here is equal to this value. Then I have just put the value into equation number 4. I can also put the value here, that will also give the same value. So from here v is equal to 2b. So is it clear? Is this clear? Is the point clear? Hello. Have you understood? Have you understood?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Okay. If that is the case, so that brings to the conclusion of today's session. So we will meet on Monday next week. So this was one, exception because I had to attend the PMRF symposium. So that's the thing. So we'll meet on next Monday then. Okay. So take care.